Okay, like this last one, we have a fraction bar with an expression in the fraction. So um, here's how we're going to do it. We, of course, write the original equation untouched. And then we say, okay, if there's invisible parentheses around this, right, then we need to undo the divided by 2 before we do anything else. So we multiply both sides by 2 because the inverse operation of divided by 2 is times 2. So we do the left-hand side 4 times 2, right? 2, and then everything from the left-hand side goes in parentheses, right? It equals 2, and then everything from the right-hand side goes in parentheses. We're essentially doubling both sides, and it'll stay equal. Now, next step we're going to do is we're going to simplify it. 2 times 4 is 8, and the whole idea of the times 2 was to undo the divided by 2, so these two parts go away. They're inverse operations, and we're left with 8 equals a plus 10. And now what do we need to do? Well, we need to isolate the variable, so we need to get rid of that plus 10 by subtracting 10 from both sides. We do 8 minus 10 equals a plus 10 minus 10. All we're left to do now is simplify. 8 minus 10 is negative 2. And this plus 10 minus 10 right here cancel out, leaving you just with a. So negative 2 equals a. For our proof, we say original equation first, 4 equals a plus 10 over 2, and then we rewrite that original equation with parentheses where the variable was. And we fill it in with the value that we know it to be, or believe it to be, which is negative 2. Okay? Now we're going to treat the right-hand side as its own expression that we're going to solve. Now look up top, remember I said that there's parentheses there? That means that now that we know the value of a, or we believe we do, this is the first thing that we're going to do. Okay, so the 4 is just going to stay the same. We're just dealing with this side. Okay, negative 2 plus 10 is 8, and so we've got 4 is equal to 8 divided by 2. And of course, 8 divided by 2 is 4, and so we've got 4 equals 4. Check. That's done.